Today I'm going to talk to you about laws of exponents. Let's review the definition of an exponent. So first off, a power is a product of repeated factors. The base of a power is the repeated factor, and the exponent of a power indicates the number of times the base is used as a factor. So let's look at our example here. We have the base of 3 raised to the exponent of 4, which tells us that we're going to multiply 3 4 times. So 3 to the 4th power is 3 times 3 times 3 times 3. All right, the first important rule that I'm going to go over is called the zero exponent. If we ever had a base number raised to the exponent of 0, that is always going to equal 1. Except for if the base was 0, then that answer is undefined. We can look at an example down below. It says 4 raised to the 0 power equals 1. It really doesn't matter what the base is. As long as it's not 0, it will always equal 1. And the same algebraically, we can use this rule on a variable as well. If we had a raised to the 0 power, that is always equal to 1. We could have x raised to the 0 power, and that is always going to equal 1. The next rule I'm going to talk to you about is called the product of powers property, or the products of powers rule. This says that if we multiply two powers together with the same base, we're going to add the exponents. So let's look at the example. We have 4 raised to the 2nd power times 4 raised to the 3rd power. Because those bases are the same, or the number 4, the base is the same, then we can add the exponents together to simplify this, and we get 4 to the 5th power, because 2 plus 3 is 5. Same works algebraically. We have a raised to the m power times a raised to the n power. Because we have the same base of a, we can add those exponents, and our simplified form of this is a to the m plus n. So let's put this rule into use. Let's work through some examples. So number 1 says 2 to the 4th power times 2 to the 3rd power. Because our base is the same, we can add our bases together, and this becomes 2 to the 4 plus 3 power, and the simplified version is 2 to the 7th power. Number 2, we have 7 to the 5th power times 7 to the 7th power. To simplify this, we are going to write our base, and then we're going to add our exponents. And this simplified is going to be 7 to the 12th power, because 5 plus 7 is 12. We can do the same with fractions. I know this is hard to read, but it is 1/2 raised to the 2nd power times 1/2 raised to the 5th power. So we can write this as 1/2 raised to the 2nd plus 5th power, and this simplified would be 1/2 to the 7th power. The next one says negative 3/5 to the 3rd power times negative 3/5 to the 3rd power. So this simplified would be negative 3/5 raised to the 6th power, because 3 plus 3 is 6. Now let's look at some algebraic examples. We have x to the 5th power times x to the 11th power. So this would be x raised to the 5th plus 11th power, or we can simplify this even further, x to the 16th power. Our next example is y to the 3rd power times y. When y is by itself, we understand that there is an exponent of 1 here. So when we add this together, we have y to the 3 plus 1, which is simplified to y to the 4th power. All right, there's one more important, actually, I think there's two more important laws of exponents I'm going to go over with you today. The next one is called the power of powers property. This states to find a power of a power, multiply the exponents. So if we look at our numerical example here, we have 4 raised to the 6th power, and then we have parentheses raised to the 3rd power. So that's really taking 4 to the 6th and multiplying it 3 times. So that would be 4 to the 6th power times 4 to the 6th power times 4 to the 6th power. We could use the previous rule to help us solve this problem, or we just know that if we have a power raised to a power, we multiply those exponents. So this becomes 4 to the 18th power. Same thing with algebra. We have a to the m power raised to the n power. We would multiply those exponents. And we'll go over more examples in a minute. Lastly, we have the power of a product property. And this states to find a power of a product, find the power of each factor and then multiply. So for example, if we had 3 times 2 in parentheses raised to the 5th power, we can simplify that to be 3 to the 5th power times 2 to the 5th power. We cannot simplify this any more than that because 3 and 2 are 2 different bases. They're not the same base. Same thing algebraically. If I had a times b raised to the m power, that is simplified to be a to the m power times b to the m power. So let's look at a couple examples. So the first 3 examples look like they're practice from the previous rule that I had talked about. So these, because they're the same base, we are going to add the exponents. So number 1 would be 6 to the 6th power. Number 2 is going to be negative 1/2. And then that's to the 3rd power and to the 6th power. 3 plus 6 is 9. And then number 3 says z to the 1st power. And remember, there's an understood 1 there. Times z to the 12th power. 1 plus 12 would be z to the 13th power. All right. Moving on to the next example, we have 4 raised to the 4th power, and then that is raised to the 3rd power. Our rule states that when we have this, we can multiply the exponents. So this would be 4 raised to the 4 times 3 power, and 4 times 3 is 12. So the simplified version of this would be 4 to the 12th power. Number 5 is y to the 2nd power raised to the 4th power. Algebraically, we can still multiply our exponent. So 2 times 4 is 8, so this would simplify to y to the 8th power. Number 6, we have negative 4 raised to the 3rd power and then raised to the 2nd power. We're going to multiply our exponents to simplify this, and we are going to get negative 4 to the 6th power because 3 times 2 is 6. All right, moving on to number 7. We have 5 times y raised to the 4th power. To simplify this, we are going to raise 5 to the 4th power and then y to the 4th power. You could simplify this even more and do 5 to the 4th power in your calculator to get that equivalent to 625. So we could simplify this just a little bit more and we could get 625 y to the fourth power. Number 8, we have a times b. Remember, when we don't have a symbol in between there, that means multiplication. So we need to apply that exponent to both of those variables. So the simplified version of this would be a to the fifth power times b to the fifth power. And then number 9, we are going to apply that exponent to both, actually all 3 of the factors. We have a half, m, and n. So if I take a half and square it, I'm going to get 0.25. So this would be 0.25 m squared n squared. That concludes our video on the first part of laws of exponents.